This video showcases the static eBPF code security analyzer developed in Elastic. The static eBPF code security analyzer is one of the developer support tools provided by the project. It supports the C programming of the eBPF applications that are part of the Elastic architecture. The bytecode of the eBPF Linux kernel extensions must pass the eBPF verifier's safety and security checks to be loaded and executed in the kernel. Such checks ensure the code is free from safety and security issues. Since the introduction of eBPF, the eBPF code development productivity has been hindered by the difficulty often encountered by programmers in understanding and fixing the failures reported by the eBPF verifier. Although the verifier reporting capabilities have recently been improved, this issue has not yet been solved because the verifier reports errors related to the compiled bytecode rather than the source C code used by the programmer. The only reference to the source code is the line of text associated with the bytecode that triggered the error. Even this reference is not precise, since the file name and line number are missing. Even more importantly, when the eBPF verifier informs that the program has been rejected, it usually provides minimal or no insights into why. From the verifier output, the cause of the reported error is often tricky to understand, and the verifier provides limited or no suggestions on how to fix the reported issues. Even when present, they are related to the bytecode only. Elastic Static eBPF Code Security Analyzer is a development utility for eBPF C programming developed within the Elastic project. It addresses these issues by providing precise and easy-to-understand messages directly related to the C source code, pointing out the security issues that prevent the verifier from accepting the code, what caused them, and suggestions for fixing them. The tool named PrettyVerifier works by analyzing the verifier's output, the C source code, and the object file containing the bytecode generated by the Clang C compiler. Now, let's show PrettyVerifier in action, using a couple of eBPF programs affected by security issues. The first is an XDP hook that inspects incoming packets and extracts the TCP source port if present. As you can see, the program first performs bound checks on the Ethernet and IP addresses. Then, if the protocol is TCP, it computes a pointer to the TCP header, which is then used to extract and print the source port. Let us try to compile and load the program without the PrettyVerifier. Here is what we obtain. First of all, the output informs us that the program load failed. Then, it reports the program's bytecode with the associated C code instructions. Finally, it informs us that the program was rejected because of an invalid access to packet, with offset information referring to register R1. Let us now try to compile and load the program again, but including the PrettyVerifier. Here on the right is what we obtain. After the output generated by the eBPF verifier, we can see the PrettyVerifier enhanced output. It includes the error reported by the verifier, followed by a precise reference to the file and line number of the C statement that caused the error. It also provides an explanation of the reason for the error and a suggestion on how to fix it, specifying that the attempted access can be 16 bytes over the upper bound. According to the suggestion and the knowledge provided by the tool, let's now correct the C source code by introducing a bound check on the pointer used to access the source field. Now we try to compile and load the fixed program. The verifier accepts the fixed program as expected. Now we are going to demonstrate another example of PrettyVerifier in action, illustrating how it responds to a different error message from the eBPF verifier. In this case, we are using the same XDP program as before, representing a real-world use case, but this time we introduce a different bound check. Here, the program converts the pointer into an integer before performing the check. It is important to note that this is a pointer cast, which is considered unsafe for security reasons and should generally be avoided. As observed, the compiler issues a warning regarding the cast, and the eBPF verifier also reports a corresponding error, stating that the left shift operator is prohibited on pointers. Now, let us examine how PrettyVerifier addresses this issue. PrettyVerifier reports the same error, but supplements it with a precise reference to the file and line number where the issue originates. It also provides a clear explanation and a suggested corrective action. The output details why the error occurs, identifying a potential multiplication or unsafe cast operation. The compiler translates the cast operation into a left shift, which is explicitly prohibited in eBPF programs for pointers. While the verifier mentions this restriction, Pretty Verifier provides additional context. It explicitly informs the developer that, in pointer arithmetic, only addition and subtraction are permitted. This insight gives the developer information that would not be immediately apparent from the verifier output alone. By replacing this unsafe bound check and reintroducing the fix applied in our first example, the program is now safe and can execute successfully. Pretty Verifier is open source and available on the NetGroup POLITO GitHub repository. So far, the tool has been validated with tests that cover the most common validation errors. In the next reporting period, the tests will be completed to measure the project KPI targeted by the tool. Thank you for your attention.